Two integrated drive generator units, or IDGs, are installed. Each IDG contains a generator and constant speed drive unit in a combined housing. The IDGs can be disconnected from the engine by a momentary, guarded generator drive disconnect switch on the AC control panel. Disconnect of the IDG is irrevocable in flight. The IDGs can only be reset on the ground by maintenance. The action to disconnect an IDG is normally only taken in response to an illuminated drive light in the generator drive disconnect switch and an ICAS advisory message of left or right generator drive. The drive light indicates that the associated IDG's oil temperature is too high and/or the oil pressure is too low. After performing the drive disconnect, the illumination of the generator control switch off light indicates that the IDG has disconnected. In this situation, the generator control switch remains in the on position with the on light displayed and the flow bar in view. However, the illumination of the off light in this switch indicates that the generator breaker has opened. Now we'll describe the generator control switch and the IDG disconnect switch for normal operations. Before engine start, the generator control switch is normally in the on position with the on light, flow bar, and the off light in view. The off light indicates the generator breaker is still open at this time. With the switch on, the generator breaker is armed to close when the generator is putting out proper power. The generator drive disconnect switch drive light and the generator control switch off light remain illuminated until the engine is started. The drive light extinguishes as the IDG oil pressure builds up, followed by the off light extinguishing as the engine reaches idle RPM. The engine-driven generator, in accordance with the AC bus power priority, automatically replaces external or APU electrical power connected to the associated AC bus. After the generator is online, if a fault is detected, generator fault protection will cause the generator switch off light to illuminate, and an ICAS advisory message of left or right generator off is displayed. If the APU is operating, its generator will automatically take over for the failed engine generator. If the APU is not operating when a generator fault is detected, the opposite generator will pick up the unpowered AC bus through the cross-tie bus. The APU generator is a third electrical power source. On the ground, it may be used in lieu of external electrical power. The APU is normally started before pushback and used to power the aircraft until the engines are started. On the ground and in flight, the APU generator may be used as a substitute for one or both engine-driven generators. Electrical power from the APU flows through the APU generator breaker to the tie bus. The APU generator control switch normally remains in the on position.
Regardless of APU operation, the APU generator off light will not normally illuminate when the switch is on. The APU generator off light indicates that the APU generator control switch is selected to off, or that a generator fault has isolated the APU generator.
Selecting the switch to on, flow bar in view, causes the off light to disappear, APU operating or not. With the control switch on, the APU generator breaker operates automatically according to the priority system. APU electrical power distribution is through the tie bus. Providing external power is not connected to the tie bus, and both engine-driven generators are not operating. APU generator electrical power is applied to both main AC buses through the bus tie breakers. As soon as an engine-driven generator comes online, the bus tie breakers of the side powered by that engine generator opens automatically to isolate that side from the APU generator to prevent paralleling of two power sources. The engine-driven generator powers the respective AC system, and the APU continues to power the other AC system. When the second engine is started, the bus tie breaker of the side powered by that engine generator opens automatically to isolate that side from the APU generator to prevent paralleling of two power sources. The APU generator has been automatically removed from both AC systems. However, it remains as a backup power source in the event of a failure of an engine-driven generator. When the APU shuts down, the APU generator is no longer available. Before we finish our APU generator discussion, let's discuss an APU generator fault indication. With the APU control switch in on and APU running, the off light, in combination with an ICAS advisory message of APU generator off, indicates an APU generator fault. An external power receptacle on the right side of the airplane just after the nose gear allows connection of an external electrical power source. Although both APU and external power connect to the bus tie, only one can be on the bus tie at a time. Paralleling of power sources is not possible. An illuminated available light in the external power switch indicates that the external power generator is producing acceptable AC electrical power. External power must be manually selected. Pushing the switch to on closes the external power contactor and also trips off the APU or the engine-driven generators. After the external power is online, starting the APU will not cause the APU generator to automatically replace external power supply to the aircraft. Conversely, with external power on the AC buses when the engines are started, the starting engine's generator automatically replaces external power on its AC bus. A hydraulically driven generator, or HDG, provides a fourth generator electrical power source, albeit a much smaller generator than the engine or APU generators. The HDG is a non-time limited generator capable of operating essential systems for ETOPS operation. The center hydraulic system supplies the hydraulic power to operate a hydraulic motor to drive the generator. The HDG is automatically activated whenever both AC buses lose electrical power in flight. The HDG powers 7 buses: the captain's flight instrument transfer bus, the left and right AC transfer buses, the AC and DC standby buses, the battery bus, and the hot battery bus. Notice that the first officer's flight instrument transfer bus is not included with the HDG. There's a short time delay between the actual power loss on the AC buses and the activation of the HDG. Also, because the HDG transformer rectifier DC voltage is usually lower than the voltage of a fully charged battery, the battery discharge light may illuminate when the HDG starts operating. This can occur until the battery voltage discharges down to the output voltage of the supplied. How do you know when the HDG is activated? You would see the indicators of a dual AC bus failure, with the exception of the items that are powered by the HDG-powered buses. The immediate indications of a dual AC bus failure are a blank first officer's ADI and HSI display, blank ICAS displays, and an activated standby engine indicator.